Okay, last time we discussed already the Ohm's law and the Watt's law. For today, we'll be discussing about the DC series circuit. Series circuit, the circuit elements are said to be connected in series when they all carry the same current. So for series circuit, meaning we have the same current. Today, we'll be discussing about the DC properties of a series circuit. So these are the properties. So they have the same current flows through all the resistances. There will be a voltage drop across each resistance. The sum of the voltage drop is equal to the applied voltage. Okay. Let's go here one by one. So the same current flows. So considering we have a resistance R1, R2, and R3, they are connected in series to each other. They have the same current flowing. Now, this is our voltage source. Let's say we have a battery, negative, positive. There's only one current flowing, wherein our total current here is simply equal to the current in resistor R1 equal to I2, current in resistor R2, and I3. The current in resistor R3. So, but there's all of these current are just the same. Only one current is flowing. There will be a voltage drop across its resistances. So if we have a voltmeter or a multi-tester, so the voltage across R1, R2, and R3, if we are to sum up, so that is equal to the total voltage here, the source voltage. That's why we have this equation, V1 plus V sub 2 plus V sub 3 is equal to V total. Okay? Then, for the equivalent resistances of a series circuit. Okay, let's go over with our voltage equation here. So we have our voltage equation. We have V total that is equal to V1 plus V sub 2 plus V sub 3. So that is our equation. Okay. Then by Ohm's law, what is our V total? What is our V total by equation? Our V total is I total, R total by Ohm's law because V is equal to IR. Okay. And V1 is I1, R1, then plus we have I2, R2 plus I3, R3. Since in circuit, the current is constant, it's the same. So our I total, so we just have to cancel all the current because they are just the same. Okay, algebraically, we can cancel all the current. That is why we have this equation for the R total. So our R total simply equal to R1 plus R2 plus R3. Since we only have 3 resistors, so we just have to get the sum. Just add all the resistances. Okay? So as we see here, the total resistance here simply equal to R1 plus R2 plus R3 up to R sub n. Let's say you have 100 resistors, this is up to 100 resistors. Just sum. Take the sum. Okay, then let us solve problem number 1. Load of 10 ohms was connected to a 12 volts battery. Then let us solve problem number. The current drawn was 1.18 amperes. What is the internal resistance of the battery? Okay, so we have here a battery. Always remember that a battery has internal EMF. So we have the positive, then the negative. And a battery has an internal resistance. The internal EMF represented by big E, then internal resistance is represented by small r. In the problem, we have a load of 10 ohms. So we have here, let us represent the load resistance as big R. So it is 10 ohms. In the problem, we have a load of 10 ohms. We have here, the battery is 12 volts. So we have a 12 volts battery. Okay, let us put here the value 12 volts. Okay. The current drawn. So we have a current flowing here. Let us represent this as I. We have the given value 1.18 amperes. 1.18 amperes. Sandali ng putok ko. We have the given value 1.18 amperes. 1.18 amperes. Okay, we have our total current 1.18 amperes. So the question is, what is the internal resistance of the battery? This is the question, the internal resistance of the battery. Okay, we have our total current 1.18 amperes. Actually, this problem is only Ohm's law. Okay, so this is the total current simply equal to the total voltage. What is our total voltage? E over the total resistance. What is our total resistance? Our total resistance is simply equal to the big R plus the small r. Okay, that's it. Just have to substitute the value. We have 1.18 amperes. And then our E is equal to 12 volts. Okay. Then our load resistance, that is 10 ohms. And then plus the internal resistance. Okay. In our calculus, this is very easy. Just shift solve. Or we can manipulate this. So since we have a calculator, we can go directly with the final answer. Okay, to our non-Filipino friends, so we are using the Casio. This is Casio ES570. 570 ES Plus of Casio. Okay, so this is allowed in the licensure exam of electrical engineering here in our country, in the Philippines. So, or if you don't have this calculator, of course, we have to manipulate all the equation algebraically. Okay, so we have 1.18. Or if you don't have this calculator, of course, we have to manipulate all the equations. So our Filipino audience, if you have this calculator, so please follow the instructions. So press 1.18. Then, so that we come up with equal sign, so you better press. Now 1.18, so you press alpha calc, the CALC. And then let us use the fraction in our calculator. So in our calculator, we have this fraction, this symbol. Okay, in our calculator. So the calc is below the shift button and the fraction sign that is below the calc. The calc is CALC. Okay. Then let us input the value. We have 12. Then over 10. And then plus the small r. So let us replace the small r by the variable x. Okay. So press alpha, then close parenthesis, so that x will be put here in our equation. Okay, let us replace the small r by x. Okay, once we set up already the equation, actually this will be the equation that is planar calculator. I hope you see this. Okay, or just simply follow the what is on the whiteboard. Okay, so once you already set up, then you press now the shift calc, then equals. We have here as x the value for x. See, did you see that the value for x is 0.1694915.254, or just rounded off to two decimal places, that is 0.17 ohm. 0.17 ohm. Okay, so that is our answer. Remember that we just add the 10 and the small r because they are simply connected in series. That's why the total resistance is the series connection of the load resistance to the internal resistance of the battery. Okay, let's go over with our PowerPoint. The answer is letter. Okay, please take a look at the animation here. Okay, letter B. Okay, got it? Okay, let's head now number 2. Okay, number 2 problem. So we have an the hot resistance. The hot resistance of an incandescent lamp is 10 ohms and the rated voltage is 50 volts. Find the series resistance required to operate the lamp on an 80 volt supply. Okay, it says in our problem that we have an 80 volt supply. So put here our 80 volt battery. Okay. Then we have a lamp that is connected. But the rating of the lamp is only 50 volts. Remember that our source voltage is 80 volts. You can directly connect our incandescent lamp that has a rating of 50 volts only, wherein you have 80 volt supply. That will burn out. Okay? That will damage. Okay, we need to have a series resistance. This is the series resistance. To be able to connect our incandescent bulb. That has, of course, a resistance also. This is the resistance of the incandescent bulb. So let us represent this as the RS. Okay, we have RS. Okay, for the rated voltage of the lamp. So the rated voltage of the lamp is equal to 50 volts. Okay. And the hot resistance of the lamp is equal to 10 ohms. No? That is 10 ohms. Okay, in here, we can see here that we can calculate for the current of the lamp. Okay? Simply by Ohm's law, what is the current at the lamp? That is simply equal to the lamp voltage, which is 50 volts, okay, divided by the resistance, simply Ohm's law, over 10 ohms. So we'll come up 50 over 10, so we have 5. So that is 5 amperes. Okay? Where is that 5 amperes? This is our IL. That is our 5 amperes. Okay? This is our 5 amperes. Now, take a look here. I'll teach you something here. This is the son of the Kirchhoff, the KBL. I will introduce first the son before the father. This is the son. This is what we call the by PCL. We call this in our review center, the Marinized Powerhouse Team Review Center. We call this as the Powerhouse Chop Law. What is the Powerhouse Chop Law? Okay, please take a look. The voltage here plus voltage here is equal to the voltage here. Okay? Again, if we have a source voltage of 80 volts, We have 80 volt source. That is equal to the voltage at the load or at the lamp, that is our VL, plus the voltage drop at the series resistance, which is that is our ILRS. That is why the voltage here, VL, plus the voltage here, ILRL, or RS, I mean, RS, is equal to the voltage here. Again, the voltage here plus voltage here is equal to the voltage here. Remember that the source voltage or the largest voltage in a certain loop must be on the left side and the voltage drop on the right side. Okay? So, we have 80 volts. Put here 80 volts. That is equal to our VL. What is our VL, by the way? That is 50 volts. And then plus, what is our IL? Our IL is simply equal to 5 amperes. Then we have our RS. Okay, let us manipulate this. This is 80. Let us transpose this one. So 80 minus 50. So that is equal to 5 RS. So 80 minus 50. We have 30. That's equal to 5 RS. So we have here 5 RS. 5 RS. And of course, our RS simply equal to 30 divided by 5 or simply 6 ohm. That is the value. That is already a board exam problem. That's easy. Okay? So we have letter. What letter? Take a look here. Everybody, take a look. So letter C. Okay? Did you get that? Is that clear? Everybody, mga kaware pa, nakuha po ba? Okay, clear? Iwanag tayo ha. Okay, let's have number 3 problem. We have our RB. We have our RC. We have the source. What is our source here? 117 volts. If RA is 64 ohms, and EB, so we are given here the voltage drop. This is voltage 40 volts. So where is that? In here. Our isa B, so the value is 40 volts. 40 volts. When the current is 0.5 amperes. So take note, we have a current flowing 0.5 ampere. Calculate the resistance RC. So this is the question. Our resistance RC. Okay, so take a look here. In our figure, we can we can get the value of our total resistance. Total resistance. Our working formula, it will be the total resistance simply equal to RA plus RB plus RC. That is our working formula. Okay? Our working formula. Now, let us have the value for our RB. We can calculate RB. RB. That is our working formula. Okay, by Ohm's law, that is equal to E sub B or B sub B. Sometimes this is B, the E, it signifies the voltage. Okay, and then we have the current at resistor B. Our EB is equal to 40 volts. Then our EB is simply equal to the total current, 0.5. ampere. Of course, what is 40 divided by 0.5? That is 80. 80 ohms. Okay, we can get the value of the total resistance here. What is the total resistance? Okay, please take a look here. Total voltage, 117 volts. 117. What is the total current? So we have 0.5. Total voltage over total current, 0.5 ampere. Total voltage, 170. Okay. So our total resistance simply equal to 117 then divided by 0.5. So the answer is 234. 234 ohms. That is our total resistance. So take note that our working formula here, so we have our R total. Okay, we can substitute here. We have our R total here, 234. 234. That is equal to RA, which is equal to 64, plus RB, 80. This is 80 ohms. Then plus RC. So we can easily get now the value for our RC. So that will be 234. And then just transpose the 64 here. So that is minus 64. Then minus 80. That is equal to 90 ohms. Okay. So this is our final answer. 90 ohms. Please take a look at our PowerPoint. The answer would be letter, okay, letter D. Okay, so just add all the resistances RA, RB, and RC. Okay, let's have number 4 problem. Two 115 volt incandescent lamps A and B are connected in series. So let us draw our given. So we have two incandescent bulbs. Okay, so we have incandescent bulb A. So we are given 115 volts. 115 volts. And also this 115 volt also. So we have lamp A and we have lamp B. Okay? That is connected in series across. So we have a voltage source of 230 volts. Okay. If lamp A is rated 75 watts, and lamp B is rated 50 watts. Determine the current drawn by the series connection. So the question is the current drawn. So this is our current drawn. Shall we say this is our total current? Determine the current drawn. Okay, what will be our working formula here? Our working formula will be I total, that is equal to V total over R total. So, i-divide lang natin. Okay? So, Ohm's law. This is a simply Ohm's law. Simple Ohm's law. So, that's very basic. Okay, so the total voltage is already given to be 230 volts. We just have to solve our total resistance. What is our total resistance here? The total resistance simply equal to RA plus RB. RA plus RB. Now, given the voltage, given the power, how to solve for the resistance. How to solve for the resistance. Let's say for lump A, okay, we have a basic formula for power, right? That is simply equal to V squared over R, isn't it? Okay, so just put here, let us have the formula for the resistance. Our resistance will be equal to what? Take a look here. Okay, let us cross multiply the resistance here and also the P here. So just exchange the position. Okay, so pagpalitin mo lang to. So we have here V squared over P. Okay, so for A, let's say we have for A, RA, what is our voltage at A? The rating of this lamp, remember this is incandescent lamp. So the rating is 115 volts. 115 volts squared. And then the P is 75 watts. 75. So let us calculate this. Let us calculate 115 squared, then divided by 75. That is equal to 176.33. 176.33. Then divided by 75. That is equal to 176.33. Okay, what about our RD? 176. What is the square of the voltage? 115 also. Squared. And then we have 50 watts. So it is equal to 115 x squared, then divided by 50. So the answer is 264.5. So this is 264.5. We said that from this working formula, okay, the total resistance is RA plus RB. Okay, so let us substitute here. What is the total resistance? RA, which is 176.33, and then we have to add 264.5. 264.5. So our total resistance now is 176.33, and then we have to add 440.83. 440.83. Then we can calculate now the total current. What is the total current? So the total current simply equal to the total voltage, which is 230 volts. 230 volts, then divided by 440.83. So the total current now will be equal to, so the total current simply equal to the total voltage, which is 230 volts, 0.52 amperes. Ampere. 0.52 ampere. Okay? So our answer would be letter. What is our answer here? Ano sagot natin? 0.52. 0.52. Okay? Let's go over with number 5 problem. Okay. For number 5, a barangay power station supplies 60 kilowatt to a load. To a load over 2,500 feet, 100 square millimeter, 2 conductor copper feeder. the resistance of which is 0.078 ohm per 1,000 feet. The bus bar voltage is maintained constant as 600 volts. Determine the load current. So what is our load current? The resistance of here, so we have a power station, a DC power station. Okay, problem number 5. Let's have first the figure. So we have a power station, a DC power station. It supplies 60 kilowatt. So our PL is 60 kilowatt or simply 60,000 watts. To a load over 2,500 feet. So that is the distance from the source, 2,500 feet. Okay? 100 square millimeter to copper feeder. Okay, the resistance of which, so we are given the resistance of a conductor 0.078 ohm per 1,000 feet. Okay, so take a look here. We can solve the feeder resistance. What is our feeder resistance? 0.078 ohm per, so this is ohm per 1,000 feet. What is our feeder resistance? Okay? This is the ohmic value per 1,000 feet. Okay, so again, what is the distance of the load to the source? In our problem, that is 2,500 feet. So put here 25. This is the, okay? Then we have to multiply it by 2. Why, sir? It's because we have the resistance of the wire on this side. Okay? And also on this side. Okay? Up and down. So we have two conductors. We have to consider the resistance of each conductor. No? So we have 1 and 2. So let us cancel first our feet. That will cancel out. What will be left is the ohm. So what is the value? So ano value natin? 0.078. Okay, then times 2,500 times 2, then divided by 1,000. So ano value natin? Our value is 0.39. 0.39. Okay, that is our value. We have a given of bus bar voltage is maintained constant at 600 volts. What do you mean by bus bar voltage? The bus bar voltage is the voltage at the bus bar. Let's say this is our bus bar, wherein you connect the terminal of the source to the feeder wire or feeder conductor here. So it is maintained at 600 volts. So put here 600 volts. Okay? So let us assume here a current of I. Okay? And then we have, let's say, let us put here VL. That is the voltage at the load. Again, by powerhouse chop-chop law. Let us assume here a current of, so by PCL, the powerhouse, PH is powerhouse. That is the name of our review center. Chop-chop law. What is powerhouse chop-chop law? Take note, the voltage here plus voltage here is equal to the voltage here. Remember that RF, I already multiply RF by 2 here because of the upside and the downside here. Okay? Nakuha ba yan? Siyempre sa taas, saka sa ibaba, kaya may times 2. Okay, Leo, are you getting me? Leo, nakuha po ba in our Zoom class?
Yes, sir. Yes,
Okay,
sir.
so John, Razi, can you follow our discussion?
Yes po,
Sana
sir.
nakakasunod po tayo lahat. Okay? Okay, si Craig. Craig ba to? Craig? Okay. Sige. Oh, ano yung powerhouse chap law natin? What is that? So, the voltage here, because voltage here is equal to the voltage here. Okay? That is the son of the Kirchhoff's voltage law. Okay? The powerhouse chap law. So, let us put here, let us put first the source voltage. That is 600 volts. So, put here 600 volts. That is equal to the voltage at the load, VL, okay, plus the voltage drop, which is equal to I multiplied by RF. By the way, what is our VL? Take a look here. So, our power, our PL here, simply equal to VL times your IL. Isn't it? That is our topic yesterday. P is equal to PI. Then, to get our VL, that is PL over IL. Or simply 60,000 divided by IL. Okay, so we have here 600. That is equal to, let us replace now the BL by 60,000. This is the 60,000. You see, we have 60,000 over IL, and then plus, what is our I? Our I is actually our IL. Huh? This is our IL. Anyway, there's only one current flowing. So we have our IL. Okay. And then we have our RF. Our RF is what? 0.39. Okay, we can shift solve this value in our calculator. And then we have our RF. Our RF is what? 0.39. Well, actually, if we are to take a look at this equation, let us solve this algebraically. So, we have here 600. Okay, let us multiply both sides by IL. Let us do some algebra here. We have to multiply this by IL, both sides. So we have here 600 IL. Okay, this is 600 IL. That is equal to, so IL will cancel here. That is 60,000. And then plus IL times IL squared. So we have here 0.39. Okay, let us form this into a standard equation for the quadratic equation. So we'll be having here 0.39 IL squared, and then minus, this will become negative. Let us transpose this one. Okay, so we have 600 IL minus 600 IL, then plus 60,000. So that is equal to 0. Okay, there will be two values because this is a quadratic equation. Let us put our calculator into mode 5.3. Mode 5.3. Mode 5.3. M is mode, and then we have 5.3. Let us get our first current. Let's say IL1. Okay, mode 5.3. So we have 0.39 equals negative 600 equals, and then 60,000 equals. Okay, this is 1430 0.95. Then we have two value actually. And then the other one is 107.5. So we have IL1, IL2, 0.95. That's the value. Huh? So we have the 107, 107.5. So we have our answer in our multiple choice. That will be letter, take a look, letter B. Okay? It's like an FM station in our country. The number one FM station. Wish, 107.5. Okay? So that's the value. Ay, nakukuha ba ako, mga kawerpa? So, will you spotlight all our Filipino audience so that our friends all over the world will see the audience? How I wish that there are some American, some Asian, some European students will go to our Zoom class. Huh? I hope they come to our Zoom class. This is open to anybody around the world, especially our electrical students, whether you are electrical engineering or electrical technology students, or even though you are not an electrical student, but you are electrical enthusiast, I mean. Okay, or let's say you are a high school graduate, you want to take up electrical engineering or even electronics engineering in college, so you may attend to our Zoom class. We encourage you. So please, how to do it? So go to our Facebook account. So our Facebook account is Marina's Powerhouse. So just press Marina's Powerhouse in our FB, and you will see our advertisements there. And we have already included the Zoom ID. So it's very easy to come into our Zoom class. So how I wish that we have some American friends, American students, okay, even British students, no, European students, okay. What else? Chinese students, no. Although our medium is English, okay. So I can speak in Chinese, okay. So how I wish that someday that we have a lot of students listening to us. Okay, let us continue our discussion. But you may copy our question, no, our solution, of course, no. Okay. We have the next topic. Okay, let us continue our discussion. So we have this topic about the voltage divider theorem. Voltage divider circuit. It is a series circuit which is used to feed other networks with a number of different voltages and derived from a single input voltage source. Where in here, in our circuit, our single input voltage source is our voltage V sub T, the total voltage. It is also called as the potential difference. Okay, so we have a basic example, two resistors in series. So we have R1 and R2. So to calculate for V sub 1, that is the voltage drop across R1. So how did we get with this equation? Take note. Take note that our I1 is equal to I total. I1 is simply equal to I total. Okay? Remember, they are connected in series. By Ohm's law, what is our I1? Simply, that is equal to V1 over R1. Then, what is our I total? V total over R total. Okay? So, we have our V1 over R1, that is equal to V total. Then, what is our R total in our circuit? Take note that our circuit is a series circuit, so they are connected in series, so we just have to add all the two resistances, R1 plus R2. Okay, so we have here R1 plus R2. Okay, so let us get our V sub 1. Our V sub 1 simply equal to V total, then multiplied by R1. So let us just cross multiply R1 here. R1 over R1 plus R2. Okay? That is our equation for V sub 1. You will see here that they are just the same equation here. V sub 1, Vt, R1 over R1 plus R2. Take a look here. So we have V sub 1 that's equal to, take a look here, V sub 1 is equal to Vt times R1 plus over R1 plus R2. Okay? So this is the value for V sub 1. What about for V sub 2? What is V sub 2 here? So, the current in the second resistor, I sub 2, simply equal to the total current. What is our I2 equal? It is equal to V sub 2 over R sub 2. Again, our total current is simply equal to, we have V total, this is V total, then over R1 plus R2. So, this is the total resistance. So, just cross multiply R2 here so that our V sub 2 will be equal to Vt, then multiplied by, so we have R sub 2 over R sub 1 plus R sub 2. So, we come up with this equation. Okay? V2 is equal to Vt R2 over R1 plus R2. Take a look here in our PowerPoint. So, we have our V sub 1 and V sub 2. If we have here V sub 1, remember that the opposite resistance is R1. If this is 1, this is also 1. This is V sub 2. If this is 2, this is also 2. Okay, so please take note of that. So this is 1, 1, 2, 2. Okay? So let us solve some examples. That the opposite resistance is R1. If this is 1, this is also 1. This is V sub 2. Problem number 6. Okay, so please take note of that. A 6 ohm load is connected to a 119.6 volt source through a pair of 0.25 ohm conductors. Calculate the load voltage. What is the load voltage? Okay, so we have a, first we have a source, voltage source. Our voltage source is 119.6. Volts through a pair of 0.25 ohm conductors. So, we have two resistors here because they are paired, no? So, this is 0.25 ohm, 0.25 ohm. Then we have 0.25 ohm. Then we have a 6 ohm load. So put here the load resistance 6 ohm. So we say this is our RL 6 ohm. This is our total voltage. Okay. Then we have our feeder resistance. Let us represent this as our RF. So we have two RF, by the way. Here. So what is the question? Calculate the load voltage. Take note we have the load voltage here. If we have a voltmeter here or multi-tester, so what will be our measured value here? So what is the question? If we are to consider the voltage divider theorem by voltage divider theorem, so we come up with VL. VL is equal to V total. V total. Okay? Then multiplied by R1. What is R1? Actually, that is the resistance RL. The resistance being measured by VL. So what is the voltage at resistance RL? So we have our VL. If this is L, this is also L. No? Okay? So let's have the sum. The sum is RL plus, let's say this is simply RF plus RF. They are connected in series. So, or simply twice of the feeder resistance. This will be our working formula. Okay? So our VL now simply equal to VT. What is our VT? 119.6, and then multiplied by RL, that is 6, all over 6, then plus that twice of 0.25 here. So let us manipulate this using our calculator. All over 6, then plus that twice of 0.25 here. So let us manipulate this using our calculator. So our answer is 110.4. That is our answer. Okay? We can have an alternative solution for this. So, well, we just have to get our VL, working formula first. What is our VL? Simply equal to IL RL. So let us get our IL here. So our IL, that is equal to, by Ohm's law, IL is the only current flowing in our circuit. That is also our total current. That is the total voltage over total resistance. Over total resistance. So our IL simply equal to the total voltage 119.6 over the total resistance. What is the total resistance? Simply the combination of these three resistors. So this is our 6 and then plus the twice of 0.25. What is the total resistance? Simply the combination of these three resistors. This is 119.6, then divided by 0.25. So the answer is 18.4. This is 119.6, then divided by. Okay, so to get our VL simply equal to IL 18.4 multiplied by RL, which is 6. So the answer is also the same, 110.4 volts. Okay, our answer would be letter. Ano sagot natin? Mga kawerpa, ano sagot natin? Letter D. Okay, letter D. Let's solve number 7. Problem number 7. It says 3 resistors, 2 ohm, 4 ohm, 6 ohm are in series connected across a DC supply of 24 volts. Find the voltage drops in each resistor. Let us make use of the voltage divider theorem here. So 2, 4, 6 ohm resistor. In series connected across a DC supply of 24 volts. Find the voltage drops in each resistor. Let us make use of the voltage divider theorem here. The 2, 4, 6 ohm resistor. Okay, so we have a 24 volt supply here. So find the voltage drop in each resistor. Anyway, we can go directly. We can go directly with our solution. Take note that the question is the voltage drop. At the 2 ohm, let us represent that as by V sub 1. Let's say this is a voltmeter. This is our V sub 2. This is our V sub 3. Okay. So our V sub 1 is equal to what? Take note that this is our R1, R2, and R3. So we have our total voltage. We can go directly with our solution. So we have our V sub 1 simply equal to the total voltage, 24 volts. Okay. Then multiplied by, what is the opposite resistance of V sub 1? And the opposite resistance is the 2 ohms. Okay. The voltage measured by V sub 1 at the 2 ohm resistance. So we have 2, okay, and then what is the total resistance? 2 plus 4 plus 6. That is the total resistance. So we just have to calculate this. So what is the value? So 24 times 2 divided by, this will become 12, right? So the answer is 4 volts. 4 volts. Okay, so let us go with V sub 2. Take a look here at our V sub 2, guys. Here, our V sub 2 is the total voltage 24. Then the opposite resistance is 4. And then divided by 2 plus 4 plus 6, the total resistance. So it is equal to, what is that value? 24 times 4, then divided by 12. The answer is 8 volts. Okay, what about our V sub 3? Okay, so our total voltage here is 24. Okay, what is the opposite resistance? We have 6 ohm. Then we have 2 plus 4 plus 6. Okay, so let us calculate. 24 times 6, then divided by 12. So the answer is simply 12 volts. 12 volts. Okay, that is our answers. Okay, that is the voltage drop. Huh? This is our answer. How to check if our answer is right or wrong? How to check? How to check, sir? If our answer is right or wrong? How to check? Just check. Check. Check and check. Okay? So, but how to do it? How are you going to check? Take a look here. Let us make use again by the powerhouse chop-chop law, by the PCL. What is PCL? Again, the voltage here plus voltage here plus voltage here is equal to the voltage here. Okay? So please take note of that. The sum of all the voltages, voltage drop, is equal to the total voltage. Okay, so we have here 24. Take note, 24 simply equal to V1 plus V2 plus V sub 3. Or simply 4 plus 8 plus 12. Will you add this 4 plus 8? That's 12 plus 12, 24. Yes, therefore, it is checked. Okay? I remember this subject when I was in college. No? So I always check my answer. I do some checking because I want always to make sure. No, medyo makulit ako dyan eh, no? Lalo na pagka examination, no? Especially during examination. Let's say our examination is 1.5 hours. I already solved all the 5 problems, the exam given by my professor in 1 hour. So I still have 30 minutes. I will not submit my paper early. I never do that. I still have 30 minutes. I will check if my answer is really correct. I'll do some checking. What do I mean? Well, of course, if you make some checking, you have to know other principle. Okay? Just like, for example, there is an electric circuit. Your professor asks you to solve in Kirchhoff's law. Okay? The instruction is only Kirchhoff's law. But I will not solve it using Kirchhoff's law only. I will try other method. Let's say the Maxwell's mesh or Thevenin's or Norton's theorem. If at least 2 methods, they have the same answer, therefore, I have a correct answer in our examination. Also in the licensure exam, do not submit early. Never do that. Please make sure of your final answer. If you can do some checking, that's the best. If you can, of course, the way of checking is knowing other method, knowing other alternative. You know, you should learn many things, not just like in a basketball game. It's like Michael Jordan. No? You should know a lot of moves. Okay? To be able to score points. Okay? You should know a lot of moves. Just like also in our studies. Okay? We should know a lot of method for us to check our final answer. That's a very good thing, especially in the licensure exam. Okay, so let us go over with problem number 8. Just like also in our studies. Okay, we have a bundled question. I call this as a bundled question. We have one problem, but that is for number 8, 9, and 10. Please take a look here at our given. A generator supplies power to a 12 kilowatt load 183 meters away and a second load of 8 kilowatts 122 meters farther from the load 2. Take a look. We have a figure. Please close up this one. So, for the given voltages, calculate. So, take a look here at our picture. Actually, we just need some principle of series circuit and chop-chop law. That's it. Although, this is quite a complex circuit, but that is just easy problem. I'll show that to you. 8, 9, and 10. So, I will redraw first our circuit. This one. Actually, I don't have to draw. It's already here. And can you see it, everybody? If you can see it clearly, I will not draw this anymore. So please focus this one. Okay. So I will not draw this anymore. Okay, I will maximize my whiteboard here. Okay. So For number 8, first, what is the question for number 8? What is the resistance of each wire of feeder from load 1 to load 2? From load 1 to load 2. What is the resistance of each wire of feeder? From load 1 to load 2, meaning the question here is simply our R1. Take note that this is our R1 and this is our R2. Okay? This is our R1. So take a look here that we are given here for our load 1. Meaning the question here is simply our, what is our load 1? This is our R1 and this is our R2. That considers to be the 8 kilowatts here. That is the 8 kilowatt. Because again, the generator supplies power over 12 kilowatt, 183 meters away. So this is our 12 kilowatts. 183 meters away from the source. This is the generator. Then there is another load here of 8 kilowatts. 122 meters farther from this load too. Okay. We are asked to find R1 first for number 8. What is the value for our R1? Let us get first our I1. What is our I1? I1 simply equal to P1 over B1. Okay? Because power is equal to BI. Power is P times I. So we have our I1. What is our power at load 1 here? What is our power? 8 kilowatts. That is 8 kilowatts. Or 8,000. Okay, then our voltage. What is our voltage? 220 volts. We have 220 volts. So let us calculate this one. 8,000 divided by 220 equals 36.36. 36.36 amperes. So that is our I1. Take a look, where is I1? That is the current here. This is your our 8,000 kilowatt load. Okay? Then let us get how to get our R1 here. Take a look at this loop. Again, we can make use of the powerhouse chop-chop law. How is it? We have a 230 volts here. This is the 220 volts. Okay, this is the 230 volts. Take a look here. The 220 here plus the voltage drop here, the R1 here, and the R1 here is equal to the 230 volts. Let us write it down. So we have 230 is equal to 220. Okay. Then plus, so the current at R1 simply I1 here. And also the current here on the downside is also I1. The I1 is the current flowing here. Okay? So, actually, we may put here the twice because of the up and the downside. So, we have our 2 I1 R1. So, therefore, we can substitute 230, then 220, then we have 2. What is our I1? 36.36. 36, then we have R1. Okay, so this is now easy. So let us manipulate this using our calculator. 230 volts. What is our I1? 36.36. Then we have R1. Okay, so this is now easy. So let us manipulate this using our calculator. 230 volts. Okay, my answer here is 0.1375. 0.1375 ohm. That is our final answer for number 8. The answer would be letter. Okay, we have letter B. 0.1375 ohm. Let us solve number 9 problem. The resistance of each wire of feeder from load 2 to the generator. What is it? So from load 2, this is our load 2 to the generator. Let us have our working equation. Take a look here. We have a 230 volts here, and we have a 250 volts. This is our source. Considering this loop, okay, 230 plus the voltage drop here on the upside and then the downside here. The up conductor and the down conductor here. Okay, let's say this is line 1 and line 2. There is a voltage drop here. Again, 230 plus the voltage drop here and the voltage drop here is equal to 250 volts. This is the 250 volts. So let us write the equation for number 9. There is a voltage drop here. Again, 250 and the voltage drop here that is equal to 230. This is the 250 volts. So let us and then plus the equation for number 9. Although we may see here that this is our I2. This is our I2. The current flowing here at load 2 here. And then plus I2. And this is our I1. Take a look. This is I2. This is I1. Then you will see here the total current. The total current is always the current that will be delivered by the source. That is the first current from the source. You will see the 250 volt source, a DC generator. Okay, it will deliver the total current. Okay, how to set up this equation? Again, the 250 simply equal to 230 plus the voltage drop here and the voltage drop here. That will be equal to 250. So we have 230 and then plus in here, so we have 250 that's equal to 230 plus the twice. Twice of what? I total. I total. I total. And then what about the resistance of the feeder from generator to load 2? That is simply R2. That is the unknown. But first, we don't have the value for our I total. Let us get first our I total. Okay. We'll do some a little Kirchhoff Current Law here, although we have a separate topic for that. That will be for next week, because next meeting on Friday, I'll discuss parallel circuit. So please take a look here. What is our total current? Our total current simply equal to I1 plus I2. So we have these two branches here. The total current is equal to I1 plus I2. So take note of that. I total is equal to I1 plus I2. Okay, let us calculate for the value of I2 first. That is equal to the power at load P2, which is equal to 12,000 watts. So put here 12,000. Okay, let us calculate for the value of I2 first. Then what about for the voltage? The voltage is 230 volts. So it will be equal to, so it is 12,000 then divided by 230, that is equal to 52.17, 52.17 amps. 12,000 divided by 230, 52.17. Okay. So our total current, so we just have to add I1. We already have the value of I1. That is 36.36, then plus 52.17. So that is equal to 88.53. Okay. Take a look here. We will substitute the values. Okay, we have 250. That is equal to 230. Then plus the twice of I total 88.53. Okay. Then we have here our R2. So our R2 now will be equal to what? So let us shift solve this equation. 250. Then press now alpha calc 230. Then we have plus 2 times 88.53. Then alpha, close parenthesis, then shift calc equals. Okay? So my answer here is 0.1129. 0.1129 ohm. Okay? So my answer here is 0.1129. Okay, so take a look here for number 9. What is the letter of our answer, guys? Please take a look here. Okay. So the answer here would be letter. We have letter C, 0.1129 ohms. Okay, so let us have now the efficiency of transmission. What is the efficiency of transmission? The answer here would be letter. We have letter C. Okay, for number 10. Okay, what is the formula for the efficiency? Again, I gave to you this formula before. For the efficiency of transmission. Okay, for number 10. Okay, what is the formula for the efficiency? Again, I gave to you this formula before. For the efficiency of transmission. For number 10, I gave to you this formula. The efficiency is equal to the power output over power input times 100%. Or efficiency would be equal to the power output over power output plus power losses. The power loss. We can calculate easily the power output. And take note that the power output is always the power at the load. For this case, we have two loads. We have the 8 kilowatt and then we have the 12 kilowatts. So 8 plus 12, so we have 20 kilowatts. So we already have our P sub O. What about the power loss here? The power loss, that is actually the power dissipated in the resistance of the feeder wires. Okay? So let us take a look again at our circuit. So we have our circuit here. there is a power loss. In R1, we have two R1. There's also power loss in our R2. Okay, so we have our circuit here. For the P loss 1, I put here 2 because there are two conductors, the up and the down conductor, line 1, line 2. Okay, so this is I1 because the basic formula for power loss is I squared R. I squared R. So we have here our I1. Okay, so we have our I1 squared R1 plus what is the power loss in R2 here? Take a look here that R2, the current flowing in our R2 simply equal to our I total. If this is our I total, this is also I total, right? Did you get that? This is also our I total. So we have here our 2 times I total squared. We have R sub 2. Okay. So let us substitute all the values twice. What is our I1? 36.36 quantity squared. Then R1 0.1375. Then plus twice I total. I total is 88.53 amperes. 88.53 amps I total. Then we have our R2. R2 is 0.11. I total is 88.29. Okay. So that is our power loss. 88.53 amps I total. So let us calculate. R2 is 0.11. 29. Okay. So that is our power loss. Let us calculate. So the answer here is 2133. .28 watts. So the answer here is 2133. So let us just substitute from the formula of the efficiency. The power output is always the power consumed by the load, which is 20,000. Put here 20,000 over 20,000 and then plus 2133.28 times 100%. What is now our efficiency? Okay, my answer here is 90.36%. That is my final answer. Okay. So what is the letter? Or nearest to what letter? 90.36. Okay. That is nearest to letter P. Okay, did you get that? Are you getting me, everybody? Okay, are you getting me? Okay. So please motivate yourself. Okay, so we have number 11. But before I solve that, I will discuss to you some principles of battery. Okay, so let us have now battery. Battery is a group of cells. Okay, so they may be connected in series or in parallel. If you want a high voltage output, high voltage, we have to connect the cells into series. If we want a high current, connect the cells into parallel. Okay? That will be our topic for Friday. So, let us have first all the cells in series. Let's say we have this, a battery always has internal EMF, okay, the internal voltage, and the internal resistance. We have E1, R1, E2, R2, up to, let's say, En, R sub n. Let's say you have 5 batteries, so this will become E5 and R5. Okay, so just add all the internal EMF to come up with ET. Let's say ET will be equal to E1 plus E2 plus E3 up to E5, let's say. Okay? Or if we have common cells, no, the value I mean is common, our E total simply equal to, okay, the N multiplied by the internal EMF of each battery. Okay? Our RT simply equal to N number of cells multiplied by the individual internal resistance. We may use that. Now, take a look at this equation. Let us have the basic battery equation. Basic battery equation. What is the basic battery equation? Take a look here. The voltage here plus voltage here is equal to the voltage here. So our E sub t is equal to, what is the voltage here? We have I total, we have load resistance R. What is the voltage drop here? The current flowing in RT is also our IT, plus IT, and then the small RT. What is IT multiplied by big R? Take a look here. We have here a voltmeter that is the value of voltage to the load, resistance R. So therefore, our E total simply equal to, let's say this B, let us take note that this is B total. The E total simply equal to B total because IT R is B total, and then plus our IT multiplied by RT. So this is the basic battery equation. Or simply, E is equal to B plus IR. So that is the basic battery equation. Okay? This one. I call this as EBIR. EBIR. See? EBIR. E-B-I-R. EBIR. Okay? EBIR. Okay, so let us have EBIR. Okay, so we have IR. Okay, so multiply it by I. Okay, this will become EI. That is equal to BI plus this one, I squared R. What is our EI? Our EI here. Our EI is our power input. Take note of that. So that is equal to, what is our VI? That is the load voltage. Load voltage. Or just simply our power output. That is our power output. What is our I squared R? That is the basic formula of what? Power loss. Power loss. Okay? That is why our power input is power output plus power loss. Okay? So, we have here the formula for the efficiency of a battery. Again, also, it is the power output over power input. Okay? What is the power output in our battery? What is the power output? The formula for the efficiency. Power output, simply the power here at the load side, which is simply equal to Vt multiplied by It. Okay? Power output over power output. Vt, It, plus the power loss. What is our power loss? This is our power loss. Simply equal to I squared R times 100%. Okay? So that is our formula. This is the power output over power output plus the power losses. Actually, you don't have to memorize this. Remember that the power output is equal to the power of the load. That's always. Which is equal to the V total multiplied by the I total. What is the power input? That is actually the power generated in the battery. Take a look here. Inside the cells here or the battery, so there is a total current here. That is simply equal to ET multiplied by IT. That is the power generated. So, therefore, now, our efficiency is power output, which is Vt IT, over power input, which is ET IT, times 100%. What can you say about the IT? That is just simply cancels out. Therefore, the efficiency is simply the load voltage over the source voltage. Then if you have your total, put here total, put here total. So this is times 100%. So these are the formulas, no, that we will need to use for the next problem. Okay? Okay, let us solve some problem. I will solve number 11 here. Okay, let's go with number 11. A dry cell has an internal resistance of 0.04 ohm and assume to have a constant EMF of 1.5 volts. Calculate the power delivered to 0.06 ohm resistor load. Okay, so we have a dry cell. And assume to have a constant EMF of 1.5 volts. Calculate the power delivered to 0.06 ohm resistor load. Okay, so we have a dry cell. So it has 1.5 volts. Internal resistance 0.04 ohm. Calculate the power delivered to 0.06 ohm resistor load. So our load resistor 0.06. Okay, so this is our E. This is simply our small r. Then we have here our current flowing. Okay. Calculate the power. What is the power delivered here? First, we have to get our current. What is our current? Again, this is just Ohm's law, actually. What is our total voltage? Always, the total voltage is the source voltage. 1.5 volts. First, we have to get our current. What is our current? Total voltage over total resistance. What is the total resistance? So we have 0.06. Always, the total voltage is the source voltage. Plus 0.04. So our total current will be equal to, what is the total resistance? So we have 0.06 plus 0.04. So our 15 total current will be equal to, that is our total current, 15 ampere. So let us double check. So we have 1.5, that is the total voltage over total resistance, which is the series combination of the two resistors, 0.06 and 0.04 ohm. We come up with 15. Okay. So the question is the power delivered at 0.06 ohm. The total power delivered at the load simply equal to the I total squared. Then we have here RL. What is our I total? 15. Okay. So that is 15 squared. Then multiplied by 0.06. So what is the value? The answer is 13.5 watts. Okay, so the letter would be letter A. So this is our final answer for this problem. Okay, so let us have now problem number 12. 5 dry cells in series aiding. We have E is 1.5 volt, R is 0.05 ohm, and then the load resistance is 4 ohm. Actually, this is the EMF per cell. That is per cell. That is not yet the total voltage. And then this is our internal resistance. Then this is our load resistance. We have to calculate the current I. What is the current I? So let us draw the figure for number 12. Let us draw the figure. So we have here 5 cells. 1, 2, 3, 4. Then we have 5. We have 5 cells here. So let us put here E sub 1, R1, E sub 2, R2, E sub 3, R3, E sub 4, R4, E sub 5, R5. So we have here our load resistance. Of course, there is an equivalent circuit here. So this is our E total, R total, load RL. Then we have here our I total. Okay, we can have here our load voltage V. This is our E total. Okay, so that is the equivalent circuit. Then we have here our I total. 5 dry cells in series aiding. What do you mean, by the way, what do you mean by series aiding of the cells? Because there are two types of series connection of the cell. The first type is the series aiding. What do I mean series aiding? So we have dry cells in series aiding. What do you mean, by the way, what do you mean by series aiding of the cells? Because there are two types. That is series aiding. Let us consider first the internal EMF. If we have here negative, positive, negative, positive. Take note that we have per cell is 1.5 volt. I'll just connect two cells, 1.5 and 1.5. If we have here a battery, voltmeter, I mean. Let us have a voltmeter here. What will be the measured value of this voltmeter? Remember that this is negative, positive, negative, positive. So the current will flow conventionally inside the cell from negative to positive, like this one, inside the cell. They have only one direction. You see, the current only has one direction. What will be the reading of the voltmeter? So this is 1.5 plus 1.5. This is 3 volts. That is 3 volts. That is what we call the series AD. Then the second is what we call the series opposing. Series opposing. What do we mean by series opposing? Let's say we have a cell here, negative, positive, positive, negative. So we reverse the second battery. Negative, positive, positive, negative. What will be the reading of the voltmeter here? If you have 1.5 volts, 1.5 volts, the direction of the current of the first cell is to the right and this is to the left. So take a look here, they opposes each other. That is why it is opposing, because the two battery current are opposing to each other. If they have equal batteries, value of the cell, 1.5 volt, 1.5 volts, so you'll come up with a 0 volt. And that is dangerous for the connection. That is equivalent to a short circuit. Always remember that. If you have line 1 and line 2, 220 volts at home, if you have a voltmeter here, of course, our voltmeter will read 220 volts. Here. But, if you will short these two terminals, what will happen to this voltage? The voltage will become 0 volt, and that is a short circuit or a shorted. That is the most dangerous thing that will happen to our electric circuit, the short circuit, and that causes electrical fire. Yan ang mga pinagbumula ng sunog. Sabi, sinisisi tayo lagi. Faulty electrical wiring. Okay? So, never do this. The series aiding and series opposing is being used in the transformer connection of the coils. If we have 110 volts, 110 volts, so we'll come up with 220 volts. 110 volts, 110 volts coil, this will produce 0 volt. And remember, there is an assumption for the transformer coil winding. Here. If we have, this is what we call the polarity mark. That signifies the positive. Of course, the other side is the negative terminal at a certain instant. If there is a polarity mark, that is automatically to be the positive terminal. If we have the, and then of course the other side will be the negative terminal. Well, we will discuss this in our higher studies in electrical engineering. Okay, let us have this number 12 problem. We have 5 dry cells in series AD. Let us calculate the total EMF. What is the total EMF? Simply equal to N multiplied by the volts per cell. How many cells do we have? 5 cells. Then, H is 1.5. What is this? 1.5 times 5. That's 7.5. 1.5 times 5. 7.5. You see, many students are asking me, and there are some high school students asking me, kailangan ba magaling sa math para maging engineer? May ganong tanong. Okay, so we have, okay, again, 5 times 0.05. So the answer is 0.25. 0.25. 0.25 ohm. 0.25 ohms. We have just a bit halfway to our topic. It's already 12 noon, but we will continue this. Don't worry. So, we will finish this topic. Let's take a look here. We have our E total, 7.5. Our total, we have 0.25. The question is the total current. For number 12, again, what is our total current? Our total current simply equal to the total voltage, ET, right? Then over the load resistance, RL, plus RT. RT. Okay? So let us substitute the values. So we have our ET, that is 7.5. Okay? Then over, what is our RL, by the way? 4 ohms. This is 4 ohms. 4 plus 0.25. Okay. We have a 7.5 divided by 4 plus 0.25. So the answer will be 1.76. .76 ampere. And the answer is letter. Okay, take a look here at our PowerPoint. Letter A. Okay, letter A. Let's solve number 12. These are follow-up questions. What is the total load voltage? Total load voltage. For number 13. Okay, take a look here at our PowerPoint. Take a look here, the total load voltage in our circuit. The total load voltage, V simply equal to the I total multiplied by R total. Ohm's law is simply Ohm's law. So we have here, this is our V total actually. So our I total, it will be 1.76, that is 1.76, then multiplied by 4. So our V now is equal to 1.76 times 4 equals. That is 7.04. 7.04. You see, mathematician will not use the calculator here. But engineers, let the calculator do it. Okay. See? You see, mathematician will not use the calculator here. Okay. This is letter B. Number 14. Calculate this is actually the load voltage per cell. What do we mean by that? Take a look here. The load voltage per cell, take a look at our equivalent circuit here. Please focus here. We have our total load voltage here. This is the equivalent circuit. This is the total load voltage. But what is the individual load voltage? That is actually the question. Per cell. So take a look here. The individual load voltage, we have this voltages. This is, shall we say, this is our V sub 1. Okay. V sub 1, then we have V sub 2. Then we have our V sub 3 here. Then we have our V sub 4. And we have our V sub 5. Okay, we have V sub 5 here. So please take a look. Simply, if they are just all equal, what can you say? If this is our total load voltage, total voltage V, how can you solve the individual load voltage per cell? That is the load voltage per cell. It's just simply the volts per cell simply equal to the total voltage divided by 5. So we have here 7.04 divided by 5. That is just the simple answer. Simply equal to the total voltage. So 1.41. So we have here 7.04 volts divided by 5. The answer would be letter A. Okay? Letter A. Let's have number 15. What is the power? Calculate the power loss per cell. What is the power loss per cell? Take a look here. Again. Of course, there is a total current here. There is only one current flowing because that is a series circuit. There's only one current flowing. What is the power? Calculate the power loss. Okay. For cell number 1, if we have our I1, anyway, I1 is equal to I2, 3, 4, 5, that's equal to the total current. Series circuit. That's only common circuit. There's only one common circuit. Circuit current, I mean. So, what is the power loss per cell? For number 15, the power loss per cell simply equal to what now? Well, let us represent this as already I total because there's only one current flowing squared. Then I will make use of an individual cell. What is the resistance of each cell? 0.05. So we already have the value for the total current to be 1.76 squared times 0.05. What will be the answer? 1.76 x squared times 0.05. That is equal to, that is actually 0.16 watt. If I will round this one off, no? 0.16 times 0.05. Because that is 0.15488. That is actually 0.16. And that is letter B. Okay? Can you follow? Nakuha po ba? Nakaware pa? Ano? Gising pa ba kayo dyan? Oh, nakakasunod ha? Okay. So, number 16. Calculate the power delivered to the load. The power delivered to the load is always the power output. What is the power delivered to the load here? Number 16. Calculate the power delivered. What is the power delivered to the load? The power delivered to the load power. That's equal to the load voltage. That is simply equal to the terminal voltage, V sub T, multiplied by IT. Okay, that's basic. We have V total, 7.04. Multiplied by IT, 1.76. So therefore, our PL is equal to what? We have V total, 7.04. 12.39. So therefore, our PL is equal to what? That is the power consumed by the load or the power output. This is also the power output. Okay? Okay, number 17. That is the power consumed. Okay, our answer here is letter B. Okay? Let's have now number 17. Calculate the total power loss. What is the total power loss? Our answer here is letter D, or number 17. Let's have now number 17. Calculate the total power loss. What is the total power loss? The total power loss is simply equal to, that is equal to I total squared multiplied by R total. We have 1.76 squared multiplied by R total, which is what? What is that? R total, 0.25. Squared multiplied by R total. Okay, so what will be the value? Squared multiplied by R total, which is what? What is that? R total, 0.25. My answer here is 0.77. Two decimal places. So we have 0.77 watt. That is the power loss. And this is letter C. Okay? So we have letter C. For number 18, calculate the efficiency. What is the efficiency? Although you already have the power loss, the power loss can be also calculated by multiplying the power loss per cell here by 5. That will just give you the same answer. Actually, what we did here is you already rounded it off, no? Two decimal places. Okay, approximately equal. But what is the easiest? What is the easiest formula to solve our efficiency? Power output over power input. Then the I will cancel out. I teach you that earlier. It's simply equal to VT over ET. That is the easiest. Times 100%. Power output over power input. Then the I will cancel out. Okay. So let us substitute here. What is our V total? 7.04 over ET. What is our ET? 7.5 times 100%. So what is our answer? What is our ET? 7.5 times 100. That's around 93.87%. Is our answer. Okay, the answer would be letter A. Okay? That is our answer. Okay, that's the end of the bundled question. That is for now from number 12 to 18. There are some follow-up questions I need. Okay, this is a past licensure exam problem, board exam problem. Let us solve this problem number 19. Okay, let us read the problem. A battery is formed of 5 cells joined in series. When the external resistance is 4 ohm, the current is 1.5 amperes. Okay, I will write first the given. Formed of 5 cells joined in series. When the external resistance is 4 ohm. I will not draw any more the individual cells, not showing the individual cells. I will just draw the equivalent circuit here. Well, the picture is already presented. So we have here our equivalent circuit. I will just draw the equivalent This is our equivalent circuit. Well, the picture is already presented. So we have here our equivalent circuit. This is our equivalent circuit. Okay, that is our equivalent circuit. This is our ET. Again, remember that we have 5 cells. We have 5 cells. Our ET here may be represented as N multiplied by E. This is the Emf percent. Our RT may be represented by N multiplied by the R, small r. That is the resistance percent. Remember that. Okay? We have this formula, the basic battery equation. Did you remember the EVIR? EVIR. That one. Okay, let us read again the problem. A battery is formed of 5 cells joined in series. When the external resistance, actually we have a variable resistance here. Let's say this is a rheostat. Okay, you may vary the value of resistance. There is a condition here. When the external resistance, if you adjust, when the external resistance, let's put here when. External resistance is 4 ohms. The current. What is the current? The current is 1.5 amperes. This is actually 4 ohms. Then when you adjust, when you increase the resistance from 4 to 9 ohm, the resistance of 9 ohm will give us a current of 0.75 amperes. Find the EMF of each cell and the internal resistance. This is the required in our problem. Our E and our small r. That is the question. That is the question. Okay? Again, take a look here at our basic battery equation. is equal to V plus IR. What is our V, by the way? Our V is the load voltage again. That is simply I multiplied by big R plus IR. Okay, we can factor out I. Is simply equal to I multiplied by the big R plus the small r. Okay? Now, we have the E. Okay, I will put here the total. These are the total. The total internal EMF, then this is the total current. The load resistance, then this is the total internal resistance. What is E total? The E total now is simply N times E. Okay, or simply what? Because there are 5 cells. Represent that as 5E. That is equal to I total. What is our I total for the first case? This is our first condition. 1.5 ampere. Okay, or simply what? Multiplied by load R, which is 4. Okay, so this is the first condition, and this is the second condition. So we have 4 when the current is 1.5 ampere, and then plus, what is our RT? Our RT is simply equal to what? 5 then small r, 5, then small r. Okay? So, therefore, that is our equation number 1. So, we have two unknowns. So, we better have our equation number 2. What is the second condition? Here, again, we have 5e for the second condition. What is the current for the second condition? 0.75. Then multiplied by 9. Then we have plus 5r. This is equation number 2. Take note of that. 9 plus 5r. Okay? That is for equation number 2. We may equate equation 1 by equation number 2. Take note of that. 9 plus 5r. Let us put here 1.5 times 4 plus 5r. So that is equal to 0.75, okay, times 9. This is 9 plus 5r. So let us manipulate this using our calculator. Shift solve. 1.5, open parenthesis, we have 4 plus 5 alpha x, alpha close, no? So, okay, so we have alpha calc, then 0.75, open parenthesis, that's 9 plus 5, then alpha close parenthesis. So we will replace the r by variable x, and then shift calc. The answer is 0.2. Our r is simply 0.2. Okay, that is 0.2 ohm. What about the EMF percent? This is the resistance percent. Let us take a look at equation number 1. Actually, this is equation number 1. We have 5e, that's equal to 5e. Let us just substitute. This is 1.5. So that is a 1.5. We have 5e is equal to 5e. Let us just substitute. This is 1.5. This is 5e for equation number 1. So that is a 1.5. That is equal to 1.5 here. This is equation number 1. That's equal to 5e. 1.5 multiplied by 4. Okay, 4 plus 5r. Well, that is 0.2. Okay, so shift solve. What is the value for E? 4 plus 5r. Well, that is 0.2. Okay, so shift solve. What is the value for E? So the answer is 1.5. So if that is 1.5 volts, therefore, that is letter. Okay, take a look here. What letter is our final answer? Okay, that is the answer in this licensure exam. No? So that is very, very hard. Okay, that's very hard. It's not very easy. Okay, So that's very hard problem. Okay? Not that, maybe moderate. Okay, so if you are doing many practice, problem solving, okay, the hardest problem that can be very easy for you. Kasi praktisado ka eh. Okay, sige, number 20 na tayo. This is our last problem. Number 20. Okay, this is our last problem, mga kawerpa. Number 20, so we have 3 resistors are connected in series across the 12 volts battery. This is our promise to everybody. Everyone who are watching right now. Per meeting, I will be solving a minimum of 20 items starting today. Actually, they started yesterday. Minimum of 20 items per meeting. Variations, different problems, no? So, napupuyat nga kami, kaka-prepare niyang mga yan, no? Para maibigay namin sa inyo ng, kumbaga, it's like cooking. No? We have to cook a delicious food for everybody. For me, teaching is like cooking, you know? So, it's not that easy to make some lesson plan, no? We really exert a lot of effort because we want everybody to learn, every student, not only Filipinos, okay? That's why, even though it is really very hard for me to speak English, okay, don't worry, I'll do my best for our viewers. This is our last problem. The 3 resistors are connected in series. We have 3 resistors. 1, 2, 3. Okay, so please listen. This is quite a tricky problem. You will find the choices. Take a look at the choices. It has 2 answers. But there is only one question, you see? We are only asked to find here the value of the current. Why it has 2 answers? Okay. So we have 3 resistors are connected in series across the 12 volts battery. There is only one question, you see? We are only asked to find here the value of the current. Why it has 2 answers? Okay, so let's say we have here our R1, R2, and R3 resistors. Okay? This is a 12 volts battery. So let's say we have here 12 volts battery. The first resistor has a value of 1 ohm. This is 1 ohm. Second, has a voltage drop. This is different. The given here for our B sub 2 is the voltage drop. Voltage drop of 4 volts. 4 volts. And the third has a power dissipation of 12 watts. Meaning P3. 12 watts. And the third has a power dissipation of 12 watts. Calculate the value of the circuit current. The circuit current, of course, no other than current I. What will be our working formula for this case? Just make use of the powerhouse chop-chop law. Remember, I am not introducing another law, no, to our non-Filipino students or listeners, no. We just invented the name in our review center. The powerhouse chop-chop law is the son of the Kirchhoff's voltage law. Okay, so by the powerhouse chop-chop law. Take a look. What will be our working equation? We have 12. Okay? Take a look. The voltage here plus voltage here plus voltage here is equal to the voltage here. Right? The 12 volts, take a look. What will be our working equation? That is what? We have 12. Remember, I will put here first the total voltage. By Ohm's law, the total voltage simply equal to the total current multiplied by the total resistance. Remember that. What is the total voltage? The total voltage is 12 volts. So that is equal to the current I. Okay, our total current is current I. Then what is our total resistance? Of course, that is our R1 plus R2 plus R3. And that will be our working equation. What about? We have given the resistance to be R1. Okay, we have the value for R1 here. What about for R2? Take a look here, we have our V sub 2. And that will be our V sub 2 is equal to I2 or simply I. Okay, there's only one current flowing. We may designate as just I. I multiplied by R2. So that is already given to be 4 volts. So our R2, R2 will be 4 over I. That is 4 over I, our R2. What is our P3? Our P3 is simply equal to I squared R3. That is given to be 12 volts. 12 watts, I mean, sorry. What is our R3? So it is equal to 12 over I squared. That is given to be 12 volts. 12 over I squared. The R2 is 4 over I. So let us substitute in here to our working formula here. This is our working formula. Again, we have 12. We have 12 here, and then we have I. What is our R1? Our R1 simply 1 plus R2. What is R2? R2 is 4 over I. 4 over I. And then plus 12 over I squared. See? Let us manipulate this equation. Let us distribute I here. The distributive property of algebra. This one. Let us have first, that is 12. I times 1, simply I. Plus I times 4 over I, that will just cancel out. This is just simply 4, isn't it? Because that will just cancel out. Just like here, 4 times 4 over I, the I will just simply cancel out. What will be left is just simply 4. Okay? Now, plus, what about here? So we have here I multiplied by 12 over I squared. What will happen now? By algebra, this is I, this is also I. Cancel. You have to cancel one I. So that will become 12 over I. So put here 12 over I. Okay? Let us transpose 4 here. So that will become 12 minus 4. What is 12 minus 4? That is 8. See? I'm not a mathematician. So I'm thinking, what is 12 minus 8? Oh, that is 12 minus 4. 12 minus 4. So that is 8. Okay? So that is I plus 12 over I. So that will be our equation now. So I'm thinking, what is 12 minus 8? Oh, that is 12 minus 4. 12 minus 4. Let us multiply this by I. That is I, both sides. Plus 12. 8 times I, simply 8I. That is equal to I times I, that is I squared. So plus 12 over I times I, it's simply, that will cancel out, right? That's simply equal to 12. Now, let us transpose this one, this 8I. So that will become I squared, okay? I squared, then transposing positive will become negative. Negative 8I plus 12. That is equal to 0. Now, we are now ready to calculate. This is a quadratic equation. This is very easy in our calculator. Mode 5-3. Just press in your calculator, mode 5-3, guys. That is equal to 0. Now, we are now ready to calculate. This is a mode 5-3. Then you enter. This is a numerical coefficient of 1. 1 equals, this is negative 8. Negative 8 equals, this is positive 12. Equals. Then you press another equals. X sub 1 here is 6. Okay? So, our, let's say, I1. Shall we say, the first value of I1 is 6 amperes. Another equals 2. Let's say our second value is 2 amperes. Okay? So, that will be our final answer. That is 6 and 2 ampere. Because we have a quadratic equation, that is x squared. It must have 2 roots, the x1 and the x2. Okay, got it? The answer would be letter. Okay, please close up this one. Our final answer for our last problem. That is x squared. Okay, that is letter A. Okay, guys, did you get that? And that is our lesson for today. Thanks be to God.